In this video we will learn more about temperature. What is temperature and how it affects flying? What is the relationship between temperature and aviation? That is what we will learn today through this video. Okay. So what is temperature? Temperature is nothing but the measurement of heat energy present in a body. Okay. So what is atmospheric temperature? Of course it is the heat energy present in the atmosphere. And what is the unit of temperature? As we all know, the standard unit is centigrade. We use centigrade or Celsius and Fahrenheit and Kelvin. Kelvin is actually used for calculations. And what is Kelvin? We say temperature in a scale of 0 to 100 degrees Celsius. Actually that is based on the melting point of ice and boiling point of water. Okay. Even if water turned to ice, it can be cooled further. We know some temperature like -20, -30, and in upper troposphere we can see -56.5, and in upper mesosphere we can see -90 degrees Celsius. So that means temperatures are possible even below 0 degrees Celsius. So what is the least possible temperature we can attain? Actually, I told temperature is the measurement of heat energy in any particular body, okay, in mass. That means it is a form of energy. So energy can be extracted from any body. Of course, it is possible. So up to what level we can extract that? The absolute zero of temperature, that means 0 degree of temperature is when the water turns to ice, or when the ice starts melting. Okay, that is the point when we call it as 0 degrees Celsius. And still energy is present in the ice. And of course ice is in the solid form, but still energy is present there. So we can reach up to -273 degrees Celsius, -273.6 degrees Celsius, which is called the absolute zero of temperature. Okay, so we call it as Kelvin, 0 Kelvin. That is the least possible temperature in any body, because after that further we can't cool that substance, because no energy is present in that substance in the form of heat. So that is the absolute zero, Kelvin. So how to convert from Kelvin to degrees Celsius? Simply add 273 to the degrees Celsius and you can get the Kelvin. So what is the melting point of ice, or what is the melting point of ice temperature in Kelvin? It is 273 degrees Celsius, 273 Kelvin. Okay, 0 degrees Celsius equal to 273 Kelvin. 0 Kelvin equal to -273 degrees Celsius. Okay, and then comes Fahrenheit also. Fahrenheit, what is that? It is another unit of temperature, and this you have to remember. And the formula to convert Fahrenheit into Celsius is n into Celsius by 5 plus 9 into Celsius temperature by 5 plus 32. There is a formula to convert Fahrenheit to degrees Celsius. And C is equal to 5 by 9 into F. Remember one most important thing, this question is usually asked in DGC exams. -42 degrees Celsius equal to -42 Fahrenheit. Sorry, -40. -40 degrees Celsius equal to -40 degree Fahrenheit. Okay. So, and now what are the devices used to measure temperature? Don't forget that question, -40 degrees Celsius equal to -40 degree Fahrenheit. Okay, just remember that. Then what are the devices used to measure temperature? There are a few devices which we use. And first and foremost, let me remember what is used in aircraft. We use bimetallic strips. What is a bimetallic strip? Actually, it is a strip of two metals actually. Okay, two metals are there. Okay. And they are closely fused together. But there are two metals. And temperature coefficient of one metal is not equal to that of other. Okay, expansion coefficient. When temperature, when this is heated, one metal will expand something more than the other. That means the expansion coefficient is different in two metals. In any two metals, it will be different only. So what will happen is, if we heat it, for example, this one has more temperature coefficient, then what will happen is, it will bend. Why? Because this tend to expand more, and the metal in the upper side, it won't expand that much. Then what happens? It will simply bend upwards. And if temperature is less, what will happen? The reverse, it will bend downwards. And this measure, that means the strip is here. If it is heated, it will bend like this. If it is cold, it will bend like this. This measure can be used to find temperature. That is the theory of bimetallic strips, which are used in aircrafts to measure temperature. Okay. And then comes maximum thermometer. Maximum thermometer means the thermometers used by doctors using mercury. When we go to hospital, they stick that to our tongue and all to measure fever and all. That type of thermometers are called maximum thermometers. And then comes minimum thermometers. Instead of mercury, the liquid used is alcohol. That is called a minimum thermometer. Okay. Then comes dry bulb temperature and wet bulb, dry bulb thermometer and wet bulb thermometer. What is that dry bulb thermometer and wet bulb thermometer? When a thermometer is directly exposed to the heat, ambient temperature, that is a dry bulb temperature thermometer. Okay, it is dry. The mercury part, the bulb part is dry. And in wet bulb temperature thermometer, we use a muslin cloth, soaked wet muslin cloth covered to the bulb of the thermometer. Why? From that we can get the wet bulb temperature. And what is that wet bulb temperature? We will learn after some time. Okay. So what is surface temperature? Surface temperature. This is the another point from our topic. Surface temperature is a temperature in the surface of Earth. From where it is measured? Remember this. It is measured if it is the Earth surface. Okay. It is measured from 4 feet height or 1.25 meter from the Earth's surface. Why? To avoid direct contact with Earth, we use a screen called Stevenson screen. Stevenson screen, and this temperature is measured not directly, not in the place where direct sunlight falls. It is measured from some shade and at 4 feet height. And this screen of Stevenson screen is not directly open towards the sun. It is directed towards the opposite side of the sun to prevent solar radiation directly heating up the thermometer. Okay, so this is how surface temperature is measured. Okay, we measure surface temperature in shade. 4 feet of height is there, or 1.25 meter of height. Then we use a Stevenson screen to cover the thermometer, and that also faced opposite towards the sun. Not towards the sun, not into the sun, it is faced opposite to the sun. Okay. Then comes latent heat. What is latent heat? We know there are many states of matter. The most primary ones we use are solid, liquid and gas. Okay. When something changes from solid to liquid or from liquid to gas, what happens is it is absorbing energy for that phase transition. From solid phase it is changing to liquid. That means it is melting. Melting means it is receiving energy and changing its form, its state. From liquid to gas, there also it is absorbing energy from energy, and that energy is used for the phase transition. That amount of energy required for phase transition is called latent heat. And in reverse, from gas to water, gas to liquid state, at that time what happens is latent energy is released. From that gaseous state it is released to for the transition of phase from gas to liquid, and from liquid to solid again energy is released. Okay. For example, in water vapor, in the case of water vapor, ice is there. If it has to melt, it has to absorb heat. And from water to water vapor, there also it has to absorb heat. Right? That is how the phase transition happens. And the energy required for that phase transition is called latent heat. And one more thing is that if the phase transition is happening, okay, for example, water is there in a bowl and we are heating it up, okay, and it is changing to water vapor, okay. So when we use a thermometer to measure the temperature, we can see it is 100 degrees Celsius and it is not increasing nor decreasing, right or not? Yes. Why? Because the heat energy, what happens to the heat energy supplied again? The heat energy supplied is used as the latent heat to change the phase from liquid to gas. That entire energy is used up. And as per a rough calculation, it needs about 5 times energy from 0 degree to heat water from water to water vapor than it takes from 0 degree to boiling. That means that much energy is required for water to change its phase from liquid to gas. Okay. Then comes heat transfer. What is heat transfer? It is nothing but transferring of heat from one place to another, right? So how heat transfer happens? There are certain methods. One is conduction, second is convection, then comes radiation, and some other are turbulence, upward, downward movement of air, etc. Okay, what is conduction? Conduction is nothing but heating, transfer of heat energy by touch, means by direct contact. The lowest layer of atmosphere, which is touching the ground, gets heated up from ground, means the ground is, if the ground is hot, it will heat up the air adjacent to the ground. Okay, from means earth is there, it is heated up due to solar radiation, and the air just above the earth's surface get heated up. Through this transfer of heat happens from earth to air. That is called conduction, because direct contact is there between earth and the air adjacent to the earth. Okay. Then comes convection. What is convection? The heated object itself is moving from one place to another, transferring the heat from one place to another. Where it happens? Okay, in places where suppose a hot surface is there, for example earth itself. the air adjacent to the earth is heated up. What happens to that air? That air becomes light, because more temperature means less pressure. That means it is becoming lighter by weight. What happens is it will move up. Okay, it moves up and the cold air comes down. Okay, this is a reason of wind also. So when it moves up, what happens is heat energy from below is directly transferred to the top by direct movement of the air itself. The hot body itself is getting moved to some other position. So that is called convection. Okay. Then comes radiation. Radiation, as we know, from sun to earth, we are receiving solar radiation in the form of heat. Okay. That is called a radiation. In radiation, the main point is it doesn't require a medium, because heat is coming in the form of rays. It can travel through space. Okay. And that incoming solar radiation is also called as insolation. Insolation. Incoming solar radiation. Insolation. Okay. Amount of heat energy which Earth receives from sun, that is also called insolation. And comes turbulence. Turbulence means irregular movement of air, and up and downdraft movements of air, eddy currents also causes transfer of heat. Okay. And where the insolation is highest? Insolation, okay, let us talk about insolation. Incoming solar radiation. Suppose this is Earth. Sun is heating up this much area in tropics, and sun is not like this, okay. And in polar regions, what happens is same size of beam is there in tropics and in polar region. And in polar region, what happens is there is a slanting area where the solar radiation falls, and that means this much cross-section area of light has to heat this much large area of space in poles. Okay, so even if the total energy falling is almost the same, it is being spread towards more space, more area it is being spread. So the effect of solar radiation is very less in the poles, and we can say it as zero in the polar region. Okay, because of the slanting rays. And what is the content of solar radiation? It is 46% IR, heat rays. Then comes 45% visible light. Then comes 9% of UV rays. Remember, UV rays or ultraviolet rays are harmful to skin and can cause skin cancer also. And IR rays are heat rays. That is the rays which causes transmission of heat from sun to earth. Okay, and this is in the form of short waves from sun to earth. From sun to earth, short. Earth to space, long. What it means? What is a short wave? Short waves means waves with shorter wavelength. The shorter the wavelength, the higher will be the energy. Okay. The longer the wavelength, the least will be the energy. So from sun to earth, waves will be like this. Infrared rays will be like somewhat like this, and from earth to space it will be like this. Wavelength is more in terrestrial radiation or radiation from earth. because earth absorbs heat, and any matter which contains energy re-radiates heat in the form of air, means in the form of heat rays, any body which has heat energy in it. So earth reflects back the sun's radiation which it received in the form of long waves, which is called terrestrial radiation. And insolation is the incident radiation from sun to earth, which is in the form of short waves, which has more heat energy than terrestrial radiation. Because sun is a hot body and it can emit shorter wavelength waves, and earth is a comparatively colder body and it can emit only longer wavelength waves. Okay. And what is heat budget? Heat budget is incoming solar radiation minus terrestrial radiation. It is almost zero because earth has got the same temperature for a long period. Okay, so the heat budget is almost zero. Okay, now let us talk about the amount of solar radiation absorbed or reflected by the earth. How much energy is absorbed and how much is reflected by earth? Okay, 30% of total solar radiation is reflected back. Okay, and that is reflected by atmosphere and clouds combinedly. 19% is absorbed by ozone in stratosphere. Ozone layer is there. We studied about that in the first chapter, I think. So 19% of total incident radiation is absorbed by ozone. Okay. Then 51% is absorbed by Earth's surface. Okay, that is the amount of total solar energy distributed by absorption and reflection. 30% is reflected by the atmosphere, 19% is absorbed by the atmosphere, mainly by UV, mainly by ozone layer, and then 15% is absorbed by the Earth's surface. And what happens to this absorbed energy? 70% of total absorbed energy, means the reflected energy from Earth, is absorbed by the atmosphere. Then it is eventually lost to the space. Okay, 70% is by atmosphere. Then 30% means this is about the total solar radiation. In the total solar radiation, 70% is reflected and only 30% is absorbed. Okay, and in this 30% absorbed radiation, Earth eventually loses it in the form of nocturnal radiation. Nocturnal radiation means in the night time it radiates heat energy in the form of terrestrial radiation. That is also called nocturnal radiation. Why? Because it happens at night. Okay. Now comes albedo. What is albedo? Albedo is the reflection power of Earth. Albedo, reflection power of Earth to solar radiation. Albedo is equal to reflected radiation by incident radiation. Okay. Actually, what is that? What is albedo? Albedo is the reflecting power of Earth to sun's radiation. Okay. So where the reflection is happening more? In snow, almost 80% of incident radiation is reflected. Why? Because it is white in color, it is shiny, and it won't absorb that much heat, it simply reflects. Okay. And water also reflects most of the energy incident to it. I mean oceans. Okay. Land absorbs most of the energy and it gets heated up easily and cools down easily also. And in clear weather, almost 5/6 of total energy is absorbed. Why? It is clear weather, clear sky. Clear sky simply allows the air to allow the passage of infrared rays from sun to hit the Earth's surface. Okay. So clear sky simply allows 5 out of 6 of the solar radiation to pass through and hit the earth. And when is the temperature highest and when is the lowest? Okay, this is called the diurnal variation of temperature. Diurnal variation. I think you remember the diurnal variation of pressure. When is the diurnal variation of pressure the maximum and minimum? Diurnal variation of pressure is maximum at 10 am and 10 pm. And the minimum, primary maximum is at 10 am and secondary maximum is at 10 pm. Primary minimum is at 4 am and secondary minimum is at 4 pm. Okay. So what about diurnal variation of temperature? At what time of a day the temperature is the least? The minimum temperature occurs 30 minutes at the sunrise. After 30 minutes from sunrise, the minimum temperature occurs in a day. Why after 30 minutes after sunrise? Because during night time, Earth is continuously radiating terrestrial radiation in the form of nocturnal radiation. Okay, and it won't stop even at sunrise, because sunrise are simply coming up and it is always starting to heat up the Earth's surface. So during the first 30 minutes of sunrise, there is losing energy only. It is not started absorbing. So up to the first 30 minutes of sunrise, Earth is losing energy, and that is the time when the least possible temperature is there in Earth. Okay, and when is the maximum possible temperature? This is least or minimum. Okay, maximum is 2 to 3 hours after noon. Okay, because at noon we think it is at 12 o'clock. No, even after 12 o'clock solar radiation is coming so intensely that it is simply heating up the Earth. So the maximum temperature occurs at 2 to 3 hours after noon, after mid. Okay, then what happens is simply the setting sun will cause less energy to heat up the Earth, and Earth will start re-radiating the energy at a faster pace than absorbing the energy. So this is the diurnal variation of temperature. Okay, and where does the diurnal variation is more and less? In our water surface, there is only 1% of diurnal variation of temperature. Diurnal variation is only just 1% over ocean, and over land it can go up to 20% or up to 20 degrees Celsius of change. That means about 50% of increase or decrease can happen over land. Why? Land get heated up easily and cools down faster also. Land can exchange heat faster. So diurnal variation of temperature is more in land than in water. And the difference is so steep also. And why does a cloudy night is hotter than a normal night? Normal night means without clouds. During night, cloud, as we know, is a mixture of water vapor and air, okay, and some ice particles. So what happens is, it is impermeable to the terrestrial radiation. Heat energy from Earth won't be able to pass through clouds easily. So it causes heating up of Earth's surface, or it acts like a barrier to cover the temperature from going outside. That means the Earth will remain warmer. That is why during cloudy nights we feel more warmer. Okay, and that is all about temperature. And in the next chapter we will learn about air density. Now you have some other work. You have to start attending the trial exam for temperature. Okay, and I think the topic is almost finished. Thank you.